Good morning, developers. Let's start developing. My name is Veko, and today we're gonna be taking on task 13 of the Advent of Code. Well, seems that we're got to the middle of the contest. There are 25 days in all, so we are about done with the first half. Let's see what the second half has in store. I haven't seen this task, so this is the first time I'm seeing transparent origami. You reach another volcanically active part of the cave. It would be nice with thermal imaging. Which caves are too hot to safely enter? Yeah, we have a thermal camera. When we are activated, we are greeting with enter the code found on page 1 of the manual. So we need to do some weird things in order to use our thermal camera. So tomorrow we will have some kind of a thermal thingy, which I guess we will have some kind of a matrix again. Large sheet of transparent paper is marked with random dots, including instructions how to fold it. So we have two kinds of input, I guess. Let's see. I guess those are the dots, and then we have fold along instructions. So we have two kinds of instructions. First section is a list of dots on the transparent paper. Yep, it's the regular XY pattern that we're using in development. From that pattern, fold instruction indicates a line on the transparent paper. Fold the paper up for horizontal or left. So we are folding it this way or this way. Y equals 7. Yep, we're folding along that line. Dots will never appear. This is kinda important. Dots will never appear exactly on a fold line. The result of doing this fold look like this. Okay. So we have one more line. We're folding left, and the instructions make a square. Yeah, so obviously the first part we will need to do the first fold, and for the second part we need to, I guess, finish folding the paper. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 folds. After 12 folds, I guess we will have some kind of a number that we need to display on the screen and then somehow get it. Let's actually, as usual, let's start with the small input, because we will have a bit of parsing to do. And we need a take while method. I have no idea whether, yeah, this is one of mine methods because I kinda need it. It is a more or less stupid method that will run through the array and take it while something is true. So we will need to see, yeah, take while it's not empty. and let's have console log dots. And then we can skip one line and take the false. Let's run this and see whether the dots are the dots and the faults are the faults, and whether we got the empty line somewhere. So we have 1, 2, 3, 4, 5, 6, 18 dots and 2 faults. And here we have 18 dots finishing with 9, 0 and 2 faults. So our separation of the two instructions are, yeah, correct. So what we need to do to the dots, let's have this, because we have x that is a number and y that is a number, and this is unfortunately named x, this is a line. So our input will be we will have dots, which is a dots array, and faults, which are basically a fault will have a direction, which is either x or y, and we will have the amount, which is a number, and we have an array of those. Yeah, of course we can extract this into an interface, or we can fold this inside here, but let's leave it like this for now. And what we're doing, we're not getting a number array, but we're getting an input value. So this will be input and this will be input, and part 2 and part 1 as well. So what we need to return for the dots, we will need now to map them. So for each line, well, let's do it simple. We're taking the x and the y as two values, and yeah, it's virtually identical to the number constructor, but I usually prefer this, so I'm gonna stick with it. And for the faults, well, we could use some kind of a regex, but this is, to be honest, too simple to use the regex. We have 5 and 5, 11 characters, and then we have the 12th character is always what we need. And after that we have 10, 11, 12, 13 character. The 14th character onwards is the number that we need. Let's try to write that in. Of how much? 12. Let's try it this way. Apparently I misspelled amount. I have no idea how it's spelled. Yeah, with the single M. Okay. So this one is wrong and this one is correct. Come on, it renamed it in the wrong, exactly the wrong way. Yep, that is correct. Can we do this? Not really. Maybe I don't know how, but I can always do this. No, this is okay, but I will need to see that this is this. Because we know that line of 12 is either an X or a Y, but we just cannot guarantee it. And TypeScript says, well, you cannot guarantee this, because if I change the input, it will be something different that's not an X and a Y. So this time I'm saying, you know what, it's gonna be an X or a Y. And this time it was equal. Yeah, so I lied to TypeScript and that makes me feel awful. But on the other hand, let's add just one more thing here to be sure that we are parsing it correctly for numbers that are more than one digit. So yeah, we got y7, x5 and x1, 2, 3, 4, 5, 6. Okay, removing that one, which means that we have our input in the correct way. So I will abuse this line. Dot will never appear exactly on a fold line. So I'm not gonna check if anything appears on the fold line. Which means that each time we're folding something, we can basically ignore that line and everything below it. So we have 1, 2, 3, 4, 5, 6, 7 lines, 8, 9, 10, 11, 12, 13, 14, 15. So we're losing this 7 line and we're losing the fold line as well. So if we have two x plus 1 lines, we are left with x lines. So if we have 15 lines, we are left with, that's 2 times 7 plus 1, we are left with 7 lines. And that means that the puzzle input will be in such a way that we can assume that. And we are going to assume that. Okay. Actually, I'm gonna try to run this without creating a grid. We're gonna take a fold and that's input.folds of 0. And our first fold is along x, so we will need to handle that as well. So, which means, yeah, something like this. Something along these lines, but not exactly this. So if we have an x direction of the fold, That means, so an x direction, what is an x direction? We had a y direction here, I guess, in the example, yep. An x direction means that we are doing a fold like this. So the x coordinate, if the x coordinate is larger, first of all, I'm gonna verify that assumption. If the x coordinate, that's dot dot x, is equal to the fold amount, then we need to throw a new error, and I will say dot at the fold line x equals fold amount. Yeah, this should never happen. So similarly, we can have that for the y direction. Otherwise, if dot dot x is less than the fold amount, then we just return the dot. It doesn't change. Yeah, because it's on the part of the screen, part of the grid we're not folding. And the remaining thing is that we are in the part that we are folding. And that means if we are fold plus 1, we're going to fold minus 1. If we are fold plus 10, we're going fold minus 10. So the diff is this. And that means that we are moving to actually fold amount. So we have dot x will be fold amount minus diff, which is actually positive. Let's see. Yeah, so this is technically dot, not DOM exemption, dot dot x plus fold dot amount. So means that we have 2 times dot fold amount minus dot x. Does this make sense? That thing I solved analytically. One way to find out. So we have dot here, that's on position 2, we have a fold on position 5, and we have a on position 7. So this will be 10 minus 7, this should be 3. And if we have 6, this will be 10 minus 6, it will be 4. And if we have 9, it will be 1. And it cannot be more than 9, because otherwise we're folding it wrong. It can get negative if we're folding it like that, but I guess we will always fold it at the middle. Let's see. X is kinda always the same. A small pause. We're back. And it seems like our logic is kinda correct, because we can see that the X kinda uniformly goes down, 81, then 40, and that's the last one, I think, because each fold is 1/2 of the previous one. in a reality, if we have some kind of a sheet of paper, we can fold it in one direction, literally in one spot, and that spot is on the half of the paper. So yeah, we can calculate x like that, and we don't need the div because we solved it. And the same thing we can do with the y. Dot y, and here the x equals to dot x, and the y is the y. After we're done with this, we can just say dot unique, but I don't have a unique method. I need to add it because it's basically this. The dots are objects, so yeah, I can map them to a string, and this will run for the string, and I can say this is the number of unique dots. Let's view the terminal, and we should get 17 points because one point got overlapped. Yeah, 17 points because one point got overlapped. Let's see. If we have this input, yeah, this task could be very easy, but the issue is that you need to make a lot of assumptions. So we have 785. Let's see if that is maybe the correct value. And it is. So all of my assumptions proved correct. And it is what it is. Finish folding the transparent paper according to the instruction. Obviously, that's the second part. So now we continue along. We can actually even refactor this out. And this is a fold dot. Yep. What the heck are you returning? Oh. Well, yeah, it extracted into a function that returns a function. It is okay, but I wouldn't have minded a simpler format like this. Fold and a dot. So we're getting a fold and a dot. And now I will extract this as an interface because we actually need it in a signature of a method. And this will become much simpler because we're getting a fold, which is a fold, and a dot, which is a dot. We don't need the other parameters of the functions, and that returns a dot, and we just don't need these lines. returns a dot, not a function that returns a dot. And this should be y as well. I'll actually extract this so it's a bit higher in the file. It should be right after process input. So we're giving it a fold and a dot, and we're receiving a dot back. And this is an array of folds. So we know that our fold is a fold, and that's all there is. So since we have few thingies, instead of doing this, we can do this. Const dots, not const lat. And let's slice them off. Actually, let's map them off. And this will return me a copy of the initial dots, because I don't want to mess up my input. I want to maybe look at my input afterwards. So we're running for each fold. I'm just gonna say dots are equal to dots dot map fold dot. But this won't be enough. This won't be enough because right now we just, yeah, that's the array of dots actually. So we will need to unique them. No, why not? We will just have a larger set to process, and we will have lots and lots of duplicates. So what? And this time I'm just gonna return a 0, but I will do a print matrix of dots. No. I'm gonna do this. And then let's create a that. And now we're just making the dots into a grid. For each dot of dots, matrix of dot x dot y equals 1, let's call it. How did we have it? We have actually our dots are not dots, our dots are hashes. Let's have it just like this, and we have ones and zeros, and then we just do print matrix of the matrix with the selector. When we have an x, if x is 1, then write out a hash, otherwise write out a dot. Let's see what this will print. And let's have it for the smaller, because for the smaller it should print a very nice square. Yep, we got a square. It's 5 by 5, so we have no idea whether we are printing in the right direction. It might be kind of tilted. cannot set port property 4 of undefined because I guess that my copilot flipped my values for me. The first one was a square, so max x and max y were the same. And this time Copilot knew better than me because whatever I got is flipped on its head. Max y, max x, and we have y and then x. And we have our password. It's quite hard to see it like in here, but let's see it here. We have a bit of a font difference right now. Yay! And I will do another thing. And you can see when you look at it in the smaller screen, it looks much better. But I will just use, instead of printing a dot, I will let it print nothing. And now this is our solution. FJAH, let's write it over. FJAH JG AH. So I guess that is the code we need to activate the infrared thermal imaging camera system. Let's see. Boom! Activated. We are returning to the advent calendar, and there's usually, yeah, you can see it very clearly now. FJAH, JGAH. Fjah. Sounds like Klingon. But we managed to solve this, and I guess most of the time that we are actually using is spent in printing out the input. So this is our actual input that we're printing, and then we're just returning a 0 because the method says that we need to return a 0. Of course, this can be optimized because if two dots overlap, we're keeping track of all of the dots, but we can see that this is fast enough for this case. So with that, I'm gonna be saying goodbye for now and see you tomorrow. Keep developing.